How was the tank made? The tank is one of the most powerful and most widely recognized weapons of war ever created. Its use was crucial to the victory of many countries in countless wars, and as such, its historical significance can't be overstated. The heavy-duty artillery and near impenetrable armor that they offer makes them a force to be reckoned with, and it takes a lot of effort to combat one of them. Their immense power makes you wonder when they originated and from where. How did such a powerful vehicle of war come to be? Today, join us as we answer exactly that by exploring how the tank was made. Early development of tanks. Right off the bat, let's discuss where tanks came from. They originated during World War I in response to the challenges of trench warfare. The first tanks were developed by the British in 1916 and were initially known as land ships. They were designed to cross trenches, crush barbed wire obstacles, and provide mobile firepower to infantry units. The first major use of tanks in combat occurred during the Battle of the Somme in September 1916. As you can imagine, tanks played a crucial role in breaking through enemy lines and overcoming fortified positions, which led to a significant shift in military tactics. Early tank designs were experimental and configured in a variety of ways. The British Mark I tank, for example, featured a rhomboid shape with caterpillar tracks and was armed with machine guns and artillery. Other countries, such as France and Germany, also developed their own tank prototypes during World War I, though their designs differed in terms of size, armor, and armament. These early tanks faced numerous technical challenges, including mechanical reliability, limited mobility in difficult terrain, and vulnerability to enemy artillery and infantry. The process of manufacturing early tanks was also complex and very labor-intensive. Tank production involved the coordination of multiple industries, including steel manufacturing, automotive engineering, and weapons production. Manufacturers faced challenges in sourcing materials, scaling up production, and maintaining quality control, especially during wartime. Also, the secrecy surrounding tank development during the war meant that much of the manufacturing process was conducted under strict security measures. Despite these challenges, the development and production of tanks during World War I chugged on, and its success is what set the groundwork for modern armored warfare. Designing the tank. The conceptualization and design process of early tanks was driven by the need to overcome specific challenges faced on the battlefield during World War I. Military leaders recognized the limitations of existing infantry and artillery tactics in breaking through enemy lines, particularly in trench warfare. Engineers and designers were tasked with developing a solution that could provide mobile firepower, protection for infantry, and the ability to navigate difficult terrain. Initial tank designs were often inspired by existing industrial machinery, such as tractors and agricultural vehicles, adapted for military purposes. Engineers and designers were essential to the development of early tanks, often working in collaboration with military commanders and industry experts. Their expertise was crucial in translating strategic requirements into practical designs that could be manufactured and deployed on the battlefield. Engineers focused on solving technical challenges such as developing reliable engines, designing robust suspension systems, and optimizing armor protection. Designers contributed to the ergonomic layout of the tank interior, ensuring that crew members could operate the vehicle effectively under combat conditions. The design of early tanks was influenced by a combination of technological capabilities, battlefield requirements, and available resources. Tanks needed to strike a balance between mobility, firepower, and protection, while remaining practical for mass production. Designers had to work within the constraints of existing manufacturing techniques and materials, often improvising solutions to overcome technical limitations. Also, the evolving nature of warfare and the need to adapt to changing tactics and enemy threats influenced the design of future tank models. As a result, early tank designs reflected a combination of innovation, experimentation, and practicality in addressing the challenges of their time. Materials selection. Choosing the ideal materials for early tanks was crucial to get the desired balance of strength, weight, and cost. Tanks needed to withstand enemy fire, rough terrain, and other hazards encountered on the battlefield, while remaining mobile and maneuverable. The materials used in tank construction had to be strong enough to provide adequate protection for the crew and critical components, yet lightweight enough to maintain mobility and minimize fuel consumption. And on top of all that, the materials chosen had to be widely available and feasible to work with in manufacturing. With all that in mind, early tanks were primarily constructed with steel due to its strength, durability, and availability. The hull and turret of the tank were typically made from thick steel plates welded or riveted together to form a secure structure capable of withstanding enemy fire and battlefield hazards. Other components, such as the tracks, suspension system, and engine, also relied on steel for their construction. While steel was the predominant material used in early tank manufacturing, other materials such as wood and canvas were sometimes used for non-structural components or to reduce weight. While steel was chosen to be the best option at the time, it was still relatively heavy, which impacted the tank's mobility and fuel efficiency. To help find alternatives, engineers experimented with different alloys and manufacturing techniques to optimize the balance between strength and weight. Armor and weaponry used. All tanks, including the earliest ones, employed heavy-duty armor protection. It was extremely important to ensure the survivability of the vehicle and crew on the battlefield. The primary function of tank armor was to withstand penetration and deformation caused by enemy projectiles, shrapnel, and explosives, thus safeguarding the crew and critical components housed within the vehicle's hull and turret. Early tanks utilized various types of armor to provide protection against enemy threats, including homogeneous steel armor and composite armor. Homogeneous steel armor consisted of a single type of metal alloy, typically steel, that was hardened and tempered to provide its resistance to penetration. Composite armor, on the other hand, incorporated multiple layers of different materials, such as steel, ceramic, and rubber, to enhance its effectiveness against different types of projectiles. Reactive armor, which detonated upon impact to disrupt incoming projectiles, was also developed in later tank designs to provide additional protection against shape-charged warheads and anti-tank missiles. All tank armor was rigorously tested throughout the development process. Armor plates were put through ballistic testing using various projectiles, from small-caliber bullets to large-scale artillery shells, to assess their resistance to penetration. And of course, field trials and combat experience provided the most valuable feedback on the real-world performance of tank armor, leading to further improvements and enhancements. The main and perhaps most iconic part of early tanks was the primary cannon, which gave the tank the bulk of its firepower. Early tanks were typically armed with relatively small caliber cannons or howitzers, capable of firing high explosive shells to destroy enemy fortifications, infantry positions, and light vehicles. The main gun was integrated into the turret structure, allowing the gunner to elevate the weapon to aim and engage targets effectively. In addition to the main gun, early tanks were also equipped with secondary weapons, such as machine guns, to provide close-range defense against infantry and light vehicles. Machine guns were mounted in various locations on the tank, including coaxially with the main gun in the turret, on pintle mounts on the turret roof, or in hull-mounted positions. These machine guns were typically belt-fed and could fire a high volume of rounds at a rapid rate, providing suppressive fire and anti-personnel capabilities to support infantry operations and defend against enemy counterattacks. Early tanks were also equipped with rudimentary fire control systems to assist the gunner in aiming and firing the main gun accurately. These systems typically consisted of basic optical sights and manual elevation mechanisms operated by the gunner or commander. Gun sights were calibrated to provide range estimation and elevation adjustments for engaging targets at different distances. The gunner relied on visual observation and input from the commander to acquire and track targets effectively. Despite their simplicity, these fire control systems were essential for maximizing the effectiveness of the tank's firepower and engaging enemy targets with precision on the battlefield. Since their birth during World War I, tanks have undergone significant evolution and technological advancement. Early tanks, with their relatively simple design and limited capabilities, have evolved into highly sophisticated and versatile armored fighting machines. Over the years, advancements in materials science, automotive engineering, and electronics have led to the development of faster, more agile tanks with increased firepower and enhanced protection. Modern tanks feature advanced composite armor, reactive armor, and active protection systems to withstand a wide range of threats, including anti-tank missiles and improvised explosive devices, or IEDs. They use state-of-the-art fire control systems, thermal imaging sensors, and networked communications, enabling crews to engage and destroy enemy targets with great precision. We've come a long way since then, and the militaries of the world are likely to take tanks a long way still. Hope you learned something from this video. Thanks for watching.